What's going on? Oh, all right, cool. There we go. Hi, it is Thursday. It is Thursday evening, and we have this scheduled thing here at the Lift and Shift Foundation. I am joined by members of our design team now, so I dig it a little more. It's a little exciting for me. It's not just me here on a a quiet stream by myself, waiting for somebody to chat at me. And the design team is here on a Zoom with me, so they're the screen is pinned to our desk cam right here, which you can see up at the top here. But they are in the background also. They can chat with through the stream. They can chat through our Zoom box. It's basically up to me to manage communications and let people either enjoy their privacy or hop on the screen and get into the details with me. I'm more than happy to do any of the above with our design team, and the goal always has been that I will not be the only host here. I just happen to be the founding host. So I'm excited to see how this grows as we attract more viewers and more people who join us, either on the design team or on other robot build teams who want to battle with us maybe on Saturdays, that kind of thing. But that is what this stream is for, and that is what we are hoping to have happen with a way to reach people across the country. So this is cool. And just a quick blurb about the nonprofit. We are a veteran nonprofit. We're a 501c3 and a legitimate IRS approved nonprofit organization. So we have a mandate to provide a service to the public. Our public group is veterans. We support veterans. We encourage veterans to get into science and technology, not just as a job. I'm not here trying to push people into a new job, as much as I am very interested in the fact that science and technology are just as fun as a hobby as they are in anything else. And there are so many different fields of science there's like culinary science, and that's a good one I use all the time. That graphic design, those are two things that you don't think of in STEM, but they have a place in STEM when you add the A for art and call it STEAM, which is kind of why I picked the name STEM Engine, because it's a clever play on two acronyms. And that's about it. But enough about the nonprofit. We have a design team here, and the design team helps me really, and they kind of are taking over as we grow Battle of the Bots as a program, and that part is super fun to me. That's one of my favorite parts, because I love these events that we do in person. You'll see a highlight video at the end of this. We'll probably be on for about an hour, maybe till about 7ish. I hit my head last week. I'm still a little out of it, but anyway, our design team is doing really, really cool stuff, and they're contributing to the program that we offer for veterans and their families as we connect with them and get them interested in things like robotics and graphic design and 3D printing and all of these things that look really hard, but they're not. So I'm always promoting, pitching, and propping up our work as a design team. I'm a member of the design team. It just so happens I'm also the founder of the nonprofit, but I very much chug along with the gang and want to do whatever they're doing and find ways to help them do better, do more, that kind of stuff. It's a highlight of my day and something I enjoy doing. But today, now that we're kind of like done covering all that, I'm gonna get into the things we've been doing with the design team. And one of the things we've been doing is designing this trophy for Battle of the Bots. We want to kind of design these prizes and trophies that we 3D print and we can give out during our events. And one of them is this trophy right here. That it's actually a light bulb. Ooh, if you can see it right there. So it's a light bulb, and it's part of a bigger assembly. So it snaps onto this like trophy mount, and we've been working on it for a while and kind of like giving it all these hidden features that people may or may not figure out. but I'm very excited because we're so close to the finished product here. We've been through 2 or 3 revisions, and I don't know why, but maybe it's the heat here in New York City today. But I've had I think my 4th print just failed right now today. It's a really weird set of circumstances. So printing aside, this is really cool because what you can't see here is that it's got a bottle opener on the back. So let's take it over to the big camera, and I'm just gonna switch screens now, and we'll get into this part. Oh no, not the big camera. Wait. Wrong views. Let's ditch Chrome right there. Okay, cool. All right. So that was a different model from Tinkercad, but check it out. So there's this really cool light bulb, and it's got this. Let me see if I can catch the light with it just right. Yeah, there you go. So you can see that it's a light bulb right there, and it's got all these features in it. There's a gear in the middle. It's very artistic about the idea that you know, a robotic challenge. It's all about coming up with this idea, which, you know, kind of signifies the light bulb, and this gear of you know, making something mechanical go, and the light bulbs. I love the design, but on the back of it, it is a bottle opener, and you would never guess that. This is also glow in the dark material, so I love the fact that while it just came off a printer, so it's not going to glow in the dark so much, but if we sit it out in the light and charge it for a bit, it is glow in the dark. It does work. It will like light up when you turn your lights out, and that part is also super cool. This is the bottle cap opener, and this is the way that it snaps on to the mount, the holder, the thing that you know, keeps it. And what we've been working on for a bit here, and it might be my dimensions, it might actually be the printer expanding and contracting, and that's what I was about to look at today. But you can see that this cap is so close to fitting in there, and this is a twist off cap opener. It's not going to pop things off, but there's one thing we've been working on. It is like so close to fitting right in there. You can see we were a few millimeters short last time, and we expanded it. I think it might need just like another expansion. So what I'm going to do is I'm going to measure inside here. First, I'm going to measure this bottle cap, because we've done this at 28, about 28 and a half for these bottle caps. So 28.4 right there. And even if we get the best, like the furthest ridges apart, it's still like 28.5, where you can spin this bottle cap freely. Ooh. So 28 and a half. And now I'm going to use the inside part right here, and I'm going to go, oh yeah, we can already see that is not 28 and a half. And we made this much wider, but somehow it's printing at about a millimeter smaller. So here's a funny thing about this material is this glow in the dark material is different than. Let me turn off my digital caliper here. So let's check out this this material and actually talk about the material. I was gonna try to grab the spool. Oh yes, the screen switch worked. I was gonna try to check out the spool and bring the spool out here and actually chat about it, because that's an important part of the conversation. But this is glow in the dark PLA. Polylactic acid is the name of the plastic, the material. It's very, very common in 3D printing, and what you don't realize is that this material will expand and contract as it's printed and put down on the glass bed for the printer. So as the material heats and cools, it expands and contracts, just like ice cubes in your ice cube tray. And this is how I try to think about it. So let's go back to the bigger view so you can see this block here. Imagine this is ice or water, and this is going in an ice cube tray. So as we fill it with the material, it's one volume, and then you come back later and the material is you know, overflowing from the ice cube tray because it's too much volume, because it's changed from a solid to a liquid, and in that process the volume changes differently. And the same would apply as if we went the other way, from a liquid to a gas. You could compress it much more than you could a liquid. But this is basically the same principle, or the same thing that happens with 3D printing, and every material will expand and contract differently. So this is a different kind of PLA, and I've never used this PLA before. These are the first projects that I'm designing with this PLA, and this is part of the learning process, is that this is actually contracting much more than I expected it to on the printer. So it is we designed this to be 28.8 millimeters in diameter, basically, and I mean, you can see it here. I think in the file it was 28.8 millimeters is what we landed on, and you can see right here the furthest I can get these apart is basically 20. If I push real hard, 28.15 ish. So it's contracting just slightly, and that contraction as we print is causing just enough overlap so that this will not grab the bottle cap, and that's I mean, that's cool. It's part of the learning process in designing this part, is that not only are we designing the part to fit the bottle cap, but now we're also like learning the tolerances and the specifications of the material that we're making the object out of. So we will probably have to expand this to, like, I don't know, we'll probably have to expand this part to actually let's measure. Here's what I want to measure. One thing we haven't seen in the Tinkercad space is that we have not measured the inside from ridge to ridge. We are measuring on the Tinkercad model, we're measuring this far right here, like in between these little ridges. So if I were to do this number and measure between the from basically the closest point to closest point, you can see we're kind of like 25.5. So I think we probably need to expand this out another 2 millimeters just to be safe. That'll put us at right about 28 millimeters on the inside, just under 28 millimeters. But if we expand this 2-ish millimeters, well, that should cover more expansion and give us the room we need to do. So I will probably slip in there if nobody else does on the design team first, but expanding all these parts by 2 millimeters is probably going to be our final print and our final way to make this actually twist the bottle cap off. So you can see right here, it is so very close. If I get very, very close in the camera here, you can see just how close that is right there. It's maybe 2 millimeters, like we just measured and like we just chatted about. But that was the discrepancy. Before it just kind of like wouldn't go on at all. There was no getting there. It was not a conducive way to kind of like operate. At least here I feel like I might be able to get an edge on this and twist. So it's different. But that's part of the process of designing and prototyping some of these things. If we were to put it on a different printer, it might have a different outcome, and that's why I'm for our design team, I try to stick to one specific printer that the team can share, and as we design things, I try to make sure that everything goes on that same printer. It's a Creality Ender 3, and it's about it's like 2.5 years old now, but it's a workhorse. I love it. It's just like it goes, and it not much stops it. I don't know like if anybody else has had that experience, but it's been my favorite printer so far. And I actually, like, outside of the nonprofit, I run a 3D print farm, so yeah, it's still my favorite printer, and I'm very, very happy to have it now. I've kind of hacked it a little bit now, so there's a lot of silent fans on it and things like that, but it's still like it was my first printer, so it's always my favorite. And I'm just gonna grab some water here because it is hot day. Everywhere across the country, I will encourage everyone to drink some water. I've heard it's still even, like 100 degrees in Europe this week, so everywhere around the planet, probably we should all have a little extra water over the next few days. I think here in New York City, it's probably not going to cool off until Tuesday, so good luck to everyone. Please don't start any fires outside. That's just my quick safety brief, and drink some water. But I'm gonna shift back now to the desk here because we have some other stuff, and I'm super excited about this. So if we take it back to the desk, I got these boxes last week, right before the weekend started, and they have these servo kits for our robots. So I'm gonna pull my keyboard away. I'm actually gonna open up an app. Here's what people don't know is we're our team is on Zoom, and it's kind of an open invite for anybody to join in and participate. But we're streaming to Twitch through an app called Streamlabs, and the cool part about Streamlabs is that not only can you stream from your phone, but you can download the app that lets you control the stream from your phone. So check it out. So I'm going to ditch my keyboard and get my keyboard out of the way and control do the best I can to control the rest of the stream for the next half hour, 45 minutes, well, basically just from my phone. Here's all the buttons, so I can change the view. Yep, like that, right there, and change it back. Yep, there we go. Right from my phone, right while the stream is running. One of my favorite features. So I'm gonna set this here, and I'm gonna try to get rid of the keyboard for the rest of the evening. Let's see if I'm successful with that. And I am absolutely going to drop my keyboard on the floor. I see this happening. I've got a stool right that sits right under my desk, and it's just enough for me to slip stuff there, and that's where I hold stuff like the robot. So when I pull the robot out, it's not on my desk. It's actually on the stool under the desk, and it fits perfect. But back to the desk view now that we got the keyboard out of the way. So check this out. MakeBlock makes these servo packs, and it's for the M-Bot, which is the smaller robot that we use for the Battle of the Bots events when we do them in person. But I've been told that this fits on our big Ranger tanks, so we're gonna break this box open and check it out. We have been working on a few improvements to Battle of the Bots, and one of them is increasing the difficulty level. So here's a book. This is definitely going to increase the difficulty level. Here's the box. I'm just going to toss that aside for right now. Go over there, you. Let's check it out. So there's a book. I'm a boy and I was in the Army. I'm probably not going to read this book, I got to be honest. I probably should. There's some good instructions right here. First, there's a packing list, and that's some good stuff. It's got a little ruler, servo arms, more screws, nuts, and bolts, and brass studs. I'm not so sure we need the brass. Oh, I guess maybe the brass studs will be helpful in mounting the servo. So they look like the same brass studs that come on the M-Bot that hold the M-Bot's like brain in place. But we will open this up and take a peek at it. There's a servo adjustment, so you can adjust the servo so that it's lined up in the right spot for you, so that 0 degrees in the software is 0 degrees on the motor. And you can see here's the adapter, so that you can make the wire connections. And there's a block of code that you can use. We will have to explore that because that's something we have not done yet. But there are blocks that you can snap together that say you want to set the servo to a specific degree, and there's actually more views of those blocks, and we'll dig into Blockly or MBlock soon and take a peek at that. They're saying they want the servo installed. Basically, well, let's take a break from from the book, and let's look at the parts, because I think it'll be kind of self-explanatory. So this is a connecting rod, and I'm under the impression, I've been told that we might be able to snap these off if we bend them this way, but definitely we can cut them. And the links serve as as like an arm, so we can make this an arm, and we can attach this arm to the servo. And let's check it out. So here is the servo. I'm just going to dump it right on the table. And I think what will happen is these servos, and possibly the entire box, will make their way out to the design team so that you all can create things. And hopefully we will have enough parts so that I have them here also. And we can, whatever you design, I can build on our like robots. That way, if you're driving a robot and you design something at home, I can build your design onto your robot here. But yeah, so this looks like a I don't know what this is, but it's a clear plastic, like from your shop class. It looks like a mount. And here's another one. This one definitely fits the servo, just like that. Or possibly like that. Yep, just like that. And then the screws mount on it. So this is how you would mount the servo. And then the servo arms attach here. And you would have them do certain things like that. Basically is how these work. So if I take this part away so that it's not a distraction. And this part might also be some kind of arm. Oh no, we'll come back to that. I don't think it belongs to there, because there are other parts in here. But these arms have like a teeth inside of it. You probably can't see it from here. And this part has teeth on the side of it, so they will snap in so that it's only goes one way or the other. And the voltage will come to this through here, and you will basically tell this servo you want it to be a certain degrees, or certain, like, I want to turn 90 degrees or I want to turn 180 degrees, and the brain for the robot will make that happen. There are a bunch of different arms on here. You can see there's this crossed T kind of. Then there's the double-sided arm, and then a single-sided arm. Depending on what you want to build or what you are designing, you might not. You might run into problems if you're designing something where the two arms are sticking out. You might need more support for something like this. Oh, and possibly this disc goes on here like that to give you more stability for things you are designing or building. But we will take a quick peek at that in a minute. So these are all the servo parts. I'm going to pack them back in just in this big bag for right now. And I don't want to lose the parts because I don't think I'm going to fasten them to the robot. I don't know if we're going to get to fastening them to the robot tonight. But these are all the parts that go in here. And you can see some of these screws are really, really small. And they attach right here on the shaft to hold those axles basically on. Or some of these other screws here mount the servo to that bracket. But they're all very, very tiny screws, so I don't want to lose them. So I want to put them back in the bag right now before I do something that I'm not proud of when they go flying everywhere. Cool. Alright, what else is in the box here? Oh, okay, this is the servo motor controller. Check it out. So the way the M-Bot works, and the way the Ranger works, is we get these telephone cords. They're RJ45 cables, technically, but it's an old school telephone cord, and it snaps into here. And this is how the brain talks to all the control boards. So it'll snap in there, and then the servos will attach here. And the fun part is, just like that, you're basically all connected and hooked up. So it's very easy. But the super part is, this controller board has 2 ports, so you can control 2 motors with it. And I know we have some extra servos around here somewhere. So if I'm going to send these boards out and these kits out to design team members, there's a good chance I'm going to make sure you get an extra servo. so you can do even more with it. But this is the control board, which means that this would mount somewhere on the robot. We'll have to take a peek at this in a minute, and I'll come back to this, and we'll see where we can mount this thing. And then those wires, like I said, there are a bunch of other parts in here, so I've already opened it just to snoop around. I wanted to be prepared. There's this thing, which is a it's not a sensor. It's a light module. It has four little four little LEDs on it right here, and they're not regular LEDs. They're RGB LEDs, so they can shine any color because they have red, green, and blue components in it. So you can tell it to shine a color, like an RGB color, and give it like a 6-digit code or whatever, and it will shine a color for these. And I'm not quite sure what to do with this yet. I don't really have any good ideas on this. I didn't get the boxes for this part of it. I got the boxes for the servo motors, but there's got to be something interesting to do with this here. I don't have any idea for that yet. So actually, I'll put it back in the little bag. We'll set this aside for now. What I want to do is I want to see where this fits on our Ranger, because that's where I want to go with this. You can there's some brackets here. There's some extra brackets. There's a lot of extra screws. And actually, the one thing I did say we should look at is these these things right here. These are in fact the same parts that come with the MBOT, that hold the MBOT brain to the MBOT chassis, and they're called standoffs in like if you were to go look up these parts in DigiKey or some other electrical manufacturer, these would be called standoff bolts or standoff pins. And it's a standoff because it sits these parts away from the base right here. So another part could sit up here, and it stands off from the base. So the slang term is called standoff. And there's 4 of them here. There are 4 of them that come with the MBOT. So that's kind of cool. And then there's these brackets right here. So you can make these brackets stand off from each other. Or stand off from the robot or any of those other things. And this is the point now where we're just gonna grab our Ranger tank. I'm gonna set this up here. We'll set the standoffs over here. We don't really need them, but I think it's interesting they added the standoffs. So let's get our Ranger tank out. And I can't open the box without making everybody sick. There we go. There's our Ranger tank. And this is our SaneSmart tank. And I think you might not be able to see this part on the stream, because I think I did not turn on my webcam. I think I turned my webcam on the stream but not the Zoom. But I noticed that my phone camera is like probably making you seasick with the bouncing back and forth. I got in the mail today stickers from my favorite place. The NYU runs a business incubator, and one of their incubators, one of their programs is specifically for veteran entrepreneurs. It's called the Veterans Future Lab. The Lift and Shift Foundation is a product of the Veterans Future Lab. That's where we kind of went as the founders of the nonprofit to learn how to run a business, how to start a business, how to do all the crazy stuff that none of us really want to do, like keeping track of board minutes and reporting our finances to the IRS and all that stuff that is not fun. Because robots are the fun part. But we're going to rebrand our robot here. SaneSmart has been very, very good and very, very helpful. But now that we have the sticker, I am definitely rebranding our robot as the VFL bot. So VFL is the short acronym we use for the Veterans Future Lab. Sometimes I just call it the NYU Lab, and I'm sure this sticker is childproof, so I cannot open it. There's definitely a challenge here. I need a knife. I got a small utility knife. Sometimes this works. Sometimes it just makes me look not smart. We will see if I can do this. I really thought it would be fun to just slap this new sticker on here, but if it's going to be a distraction, I'm not going to do it. I was very psyched to do this when I got the stickers. I actually asked for stickers and more stickers and everything I could. Yeah, I'm a big fan for the people who helped us get started. So, oh, I'm so close. Plus, I had to ask and confirm that this was a sticker when I couldn't get the back off the first time. Uh-oh. Uh-oh. Did I get it? Did I get it? Done. No. Uh-oh. Maybe it's not a sticker. No. Now I'll have to put the SaneSmart sticker back. But it feels like a sticker, and I thought they were sending sticker. How can I not? How can I not do this? There we go. It's done. Yes. Oh, it's clear. Look at that. Oh wait, if it's clear, I need to do the backing better. Let's Oh, okay. Let's make this challenging for me. Let's put this down. So our sticker mount is 1 inch. It's basically a 1 inch block, just like this cube here. So this mount right here is 1 inch, just like this cube. So I'm gonna be creative with my sticker here. I'm gonna put it back on the base. So close. Because I want my sticker to hold up over time. So we're going to cut it right there. And right there. There we go. Cool. Oh, that looks terrible. No, we can't do that. No? No, probably not. I'll have to think about this now. Because it's a clear sticker. I guess we're not going to rebrand our robot tonight. Boo! That was a gigantic fail on my part, but we're going to get more stickers and solve that. Put this thing away before I hurt myself. And let's get back to our robot. Okay, so here we go. Here's our robot. Here's our Ranger tank. Where are we going to put this? Well, this can go anywhere because it's just the sensor, and we're going to connect a wire basically to it. So this module can go anywhere. We need to figure out where we want to put the servo in the future. So first, let's check out how long are these little wires. These are that long. So we can put this pretty much anywhere. And they're going to snap into the side here. Right here. So this is how the thing will work. The motors will work. You will clip it in here and clip it in there. And then you'll be able to fasten the robot, the motors to it. So technically, we could put this almost anywhere. We could actually even take these screws out right here and mount it right on the side. We could do something like this. Ooh. Yeah, we could take that screw out right there and mount this right to the side. So let's test that out and test that theory and see how that works. This is a hex bolt, so I'm gonna switch my little screw around. Ooh, double-sided tape. I see. Yeah, we could use some double-sided tape. I think I might have some around. Let me spin this bad boy out of here. let's check this part out. Maybe we drop him in there. There it is. We have it mounted. We have a servo motor controller mounted. We could move this part because it's right in the way of the actual plug. Ooh. But that was rather easy. We can hide this all kinds of places now that I'm seeing this. We could slip it underneath where the battery box was. All kinds of places. But for right now, we'll leave it right here. We will snap that part in right there. You hear the click. Just like an old phone cable. There we go. And as simple as grabbing the motor and plugging it in right here. So the motor bracket has 2 ports. So it is labeled, what does that say? Here, I'm going to grab a magnifying glass. Let's see if the magnifying glass works for you up there. Ooh, it does. So you can kind of see where that says there's words on both sides of the thing. So it says slot 1 and slot 2. So slot 1 is here and slot 2 is here. That is good to know that the magnifying glass works on the screen. So I'm going to add this to slot 1 right here. Dun, dun, dun. And then we just have to figure out where we want to mount this. Where do we want to... Well, so this is our BattleBot. This is our robot. We probably want it to swing his arms and, you know, fight the other robots, right? So there's a chance we want it up here in the front this way so that it can swing on this axis. Or there's a chance we want it mounted sideways right here so that it can swing down and smash your opponent. I don't know how helpful that will be for us. Unless there's a goal, unless our goal is to like turn the button off so that we power down the other robot, which might be an option, might be something to do. But that's where our robot designers and our robot teams will probably have a lot of fun with this in the future. And I really dig this because now we can have 2 servos. We could have a servo here and a servo here. And we could have them both like sweeping like windshield washers, trying to push robots off of mats or into corners, that kind of thing. We could have them try to lift the robot up, but you know, if we put it underneath, if you put it underneath here and you have these arms that try to lift the robot up, then you could pick your robot up and push him elsewhere. There are so many different ideas to do with this. I love this. I dig this. And I think this is super easy, super simple, right? So these arms would attach not so much to like right here because that's not going to work on this thing, but what they will do, and this is probably why you need the different armatures or brackets. We'll just call them a bracket. It's possible, you know, this bracket right here, or this bracket right here is needed like that. You can kind of hear it. I just hit the end of where it goes, so it can't go any further that way. So it's at 0 or 360 degrees, or if this is a analog servo, it doesn't, I don't see the marking on it to see whether it's a complete 360 degree servo or not. Usually servos can only turn a certain angle. And if we're looking at this closely, it doesn't, 60 degrees? That can't be right. It takes at 6 volts though, it takes 0.1 seconds to turn 60 degrees. I think it's probably a 180 degree servo. without just my guess, it's probably like a cheap non-continuous servo that comes with the kit. So we're gonna turn it actually and find out. Yep, 180 degrees right there, about 180 degrees, about maybe a 190. You can see it's not quite straight right there. But if we spin it all the way around till it hits the other side, just over 180 degrees. We could say 190-ish, but yeah. So the range of motion on this is basically a half circle for this servo. So it goes half circle on one side, and you can mount this to this arm and have it spin basically in a half circle, up to a half circle. So there are a lot of options. You could also not have it go across here. You could also do something like that, so that it's only up here and it's only doing like a windshield washer type thing. But there are a lot of options. And to show this, maybe we try to plug this thing in and we try to go to our setup. So this is, I'm not prepared for this yet, but let me see if I can get to my M-Link started and get us onto the coding page. There we go. Yes. Okay, we're gonna create some code for this right now and test this out. I'm very, very excited about this. So it's opening for me right now. We've got a cable that I'm about to plug in. Oh, there we go. And just another glass of water, or drink of water. While we're here. All right. So we're going to try to plug this guy in. Actually, we're going to go to our MakeBlock website, and we're going to check out the software behind this. All right, everybody ready for this? This is where I get the crazies. There we go. That worked out well, and I still don't have my keyboard out. This is still just the mouse. So this is MBlock. This is where we're going to start. I need to increase my view. Oh no, we're going to make this tiny so we can keep it. So I can zoom in on the grid like that. Yeah, there we go. So the device that loads up is called CyberPi. We're not going to play with that. We're going to play with the MBot Ranger right here. So we're going to add the MBot Ranger as a device. So these are all the blocks that go with the MBot Ranger. We're gonna drop the upload switch so we can get when the Ranger starts. There we go. Now I'm going to zoom in so we can see the blocks. Cool. I'm not sharing my screen with you, am I? Oh, that's the terrible part. No, and I can't see the chat when I'm doing all this. Okay. We'll have to work that out. Okay. Well, let me close this other window here. And close this other window. Okay, so here's the challenge for this. We need to add new blocks. And we need to add an extension. I don't is where, extensions right here. So down at the bottom of the screen, at the bottom of all the blocks. Okay, cool. At the bottom of all the blocks, there's the extension. Yeah, there's a lag there, and I know it's super annoying. But we can pull up the device extensions, and we can add the extension for this kit. The gadgets. Is it called Gadgets Pack? What was the name of the box? Well, this one's called the MBot Servo Kit, but I think the Gadgets Kit works the same way for the Ranger. So let's check it out. Okay, there we go. So servo in port 6. Oh, I got it on the wrong end. I got the servo on the wrong side. So let's check this out. So when we add the servo, I need to first go back to, check this out. Port 6 is over here, so we need to change this to port 6 if we want to see it work. Not a big deal, because the cord reaches. Yes, just like that. So port 6, slot 1 is the block, positioned at 90 degrees. Okay, so I'm gonna come back to the stream view here. There we go. So we're gonna make our Ranger tank do a couple different moves and see if we can make the servo go. So we're gonna start the Ranger and have the Ranger make the servo go to 90 degrees to start with. Then we'll have him wait. How about, oh, I need my keyboard. 5 seconds. And then we'll go back to the gadgets thing. Oh, so the gadgets has so many cooler parts. There's that LGB module I was talking about that I showed earlier. 7-segment LED that we have not seen yet, and a limit switch, which is super a big deal because then you can stop the motor from spinning when it hits something, which is super cool. Okay, but back to the servo. So we're gonna wait 5 seconds, then we're gonna position at 0. Actually, let's do that. Let's do this. Let's start it at 0 and have it go to, let's try 180. And then have it wait 5 more seconds just in case 180 doesn't work. Oh, and go back to gadgets and make our servo go. We'll try 190 and see where 190 takes us. And then we'll go back to, we will wait again. We'll just do 1 second. Actually, we'll do 2 seconds each. 5 seconds feels like we'll be counting. 2 seconds kind of makes it feel like, okay, we can, it's gonna happen right now, kind of thing. So servo back to 90. Cool. That way when it starts we can see things happening. Okay. So that's our code. I'm going to connect to our robot. First I'm going to pick him up because he might have code in him for other stuff that's going on. Let's go back to this view so you can see the robot. So I'm going to plug the robot in. Burp, 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 burp. There we go. Robot is plugged in, powered on. Gonna connect the USB. Dun, 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 dun. So now back to our view here. We're gonna connect to the robot on COM 6. Connected. And we're gonna upload this. There it goes, uploading, start, finish. Oh, I hear the motor already. Check it out. Cool. So let me go back to this view here. So we had one set of code. The robot it doesn't go forever. It only runs one set of code. So I'm going to disconnect the motor or the computer. I'm going to turn the robot off. And we're going to come back. So I'm going to turn the robot on right now, and I'm just going to quickly go back to the screen so we can see when our robot starts. This is going to go to 0, wait 2 seconds, go all the way to 180, wait 2 more seconds, go another 10 degrees if it can, and then end at 90. And then it's going to, that's it. That's the entire program. That's all it's going to do. So every time I want this to happen, I need to turn it off and turn it back on. Because the very first block at the very top says when the Ranger starts, all of this stuff happens. So let's check it out. Ready? Go. That's 0, 180, 90. Oh, it did not go to 190. Interesting. Okay. So the range of motion is 180. So ready? I can feel the click and the power. It actually holds the position So that's very cool. So it's gonna go to 0 here, then it's gonna go to 180, and it can't go to 190. So it looks like it just stops, and then it comes back to 90. So let's actually make this look like 90 degrees this way. We will align this part here. All right, ready? Here we go. 0 to 180. It can't go to 190. So it stops at 90. So the range of motion on this is 180 degrees, which is cool to know that. We also know that 90 is here to the side, 180 is all the way up front, and 0 degrees is all the way down here at the bottom. And look, I'm trying to push on it, and it is pushing back to keep the servo at 90 degrees, which is another good thing to know. So if I turn the power off here, I felt the click. The click was the power turning off of the magnets, and the magnets like releasing the energy. So now I can actually move this to 0 if I wanted to. Where before I was pushing against the power still in the coils and the windings right here, you can kind of see. So it was doing a decent job of like pushing back against my finger. I could probably break it if I wanted to get it to leave 90 degrees, but just interesting facts to know as we look at this, take this apart, and kind of play with it. But the cool part is we have to add the extensions. So I'm gonna ditch the robot for a minute. Let's go back to the view here. We actually have to add the extension in MBlock. So when we do this, the Ranger, we have to add the gadgets pack as an extension. Ooh, there. And if we were going to use the MBot, I assume the MBot probably has this kit labeled. Yeah, so this is the MBot code. And the MBot, yeah, see the MBot has a bunch of different things. Here's the servo pack code for the MBot, which has the same stuff, just without the limit switch and without the so let's check out the difference here. So the Ranger would have the LED or the LCD, sorry, the 7-segment LCD and the limit switch, which is not in the box that we got today. But we got these two parts, and they both attach to the robot, so we can do some really cool stuff with this. I kind of dig it. And that also means that once we start battling bots again, this week should happen, we can get into the design team building more challenging stuff, and that's gonna be fun. That's gonna be exciting. But I'm not gonna sit here and clean up my mess. I'm not gonna go through too much more of a showcase or a showdown or showing everybody what's happened here. This is probably one of the cooler things we've got for this robot, and I'm excited to see what happens out of it. The thing is, now we don't need this arm because we have a design team with access to 3D printers and things. You can build your own. Oh my gosh, I just realized this is not one big arm. This is 4 arms. They're held together by rubber bands. Check that out. These are 4 thin arms, and yes, we could absolutely snap them apart. We can now make all kinds of crazy stuff with these arms. Check that out. They're very thin, but also we can design our own arms with a 3D printer. So now we can start doing things that this robot now doesn't look like the robot that we bought, the robot that that comes out of the box, because we've added sensors, we've dropped them down, we've moved everything around, but now we're adding all this other stuff, and it's starting to look like our own robot, something we are putting together ourselves, and I think that part is super cool. I'm going to do some testing on my own to see how this all works with controlling this thing straight from the boards, but overall this is pretty cool. This is pretty fancy. I just want to go back and have one more peek at this code. So we can only use the ports 6 through 10 for the all these extra parts over here on the side. So ports 1 through 5 are not available for this stuff. I think those are the digital ports. So they're probably other stuff, and maybe we can use these phone cords to create other digital sensors like buttons to push. Oh, limit switch. Oh, the limit switch goes on slot 1, just like the other stuff. Interesting. Okay. So yeah, maybe there's a way we sort out how the other ports work and dig into some of that. But that's kind of like more advanced user type stuff. And I dig this. I'm gonna kind of take some of it apart right now because this robot we're actually gonna battle with on Saturday, and I want all of this stuff not to get lost in the shuffle, because we're not going to add this stuff yet, but it's coming, and it's going to be super fun when we finally get more customized robots in the mix and create bigger challenges for us. So I'm going to do that. I'm going to put the servo back in here too, and this other arm before we lose it. Disconnected, just like that. Very cool. All right, jam that in there, and I will take my sticker so I can figure out what to do with it. Cool. And yeah, I guess I will do one more part here. We're gonna keep these because I need these to set up the extra sensors. So we're gonna keep these out and about for Saturday. And what else do we? Oh, we want to take the mount off of here. So this will mount here. I think we can mount this pretty much anywhere, which is cool. And that might be what we creep on this for the next like couple minutes. Set that aside. So where else could we put? We can mount this really anywhere. Look, I mean, we can mount this underneath here. We could actually double it up on this. We could probably try to double it up right here on this sensor right there. If you see it here, there are so many different options, so many different ways to mount this. It's possible we can mount this on the back right there into one of those screws and have it sit on the tail end of this. Very easy to just drop this in one of these screw holes right here. And make that happen. So many places to put this and have a new sensor. So I kind of dig the idea of having it up here, but that also means that it's exposed. I think the bigger deal is the mount up here for the servo motor, but we will probably add that as a Ranger hack. We will probably add that servo motor is in Tinkercad. Should be in Tinkercad. So even if it's not, we can add it into Tinkercad. So our Ranger Hacks workspace can now include, how are we going to make this happen? And that'll be like next on our list of stuff to make. But yeah, that's about it. That's how I'm going to wrap up here this evening. I'm going to go back. Oh yeah, there we go. Yes, and I have not touched my keyboard in a good half hour. That I find that oh no, I mashed the number buttons to change the wait times on the blocks. But yeah, so that was cool. That was easy. That was super easy to do, and yeah, I think that's about it. That's a decent like rundown unboxing type of setup. And I'm going to put all this stuff back in the original box now, and we will come back to this. Probably our design team will start doing this kind of stuff away from the stream, and people will never see this for weeks, maybe months, and then all of a sudden maybe one day we'll surprise, here's this thing we've been doing. You might get a peek on Thursday nights or another night, but if anybody starts watching Battle of the Bots on Saturdays, and you know this will probably never show up for a while, but yeah, the rest of this looks super fun, and I'm excited to see what we do with this as a group, because now we're not just having the same robots. We have the same parts, but we're going to start building our own robots. So mounts for the motors, different kinds of arms that can do different things mechanically. All the it'll look a little more maybe like BattleBots, and on a smaller scale. So now I need to figure out how to robot proof my apartment when things go haywire. But that'll be my problem to solve. We may try to take this outdoors for a couple events and see how that works out. I've got some places scoped out where I may be able to set up a stream and some tape and things. But yeah, we will check that out. I'm excited to do that. I'm excited to do more of this. And yeah, that's where I'm gonna end this. That's where I'm gonna wrap it up. I'm gonna mash the buttons that go bye bye, and I will leave the stream with the highlight reel, because I was sharing this just yesterday. So I'll share it again here so people can see if you're checking this out, if you are interested, if you want to come back Saturdays for Battle of the Bots. It's something we do here on Twitch, but it's also something that happens in person. We now have two events, one event scheduled for October and another one I'm working on finalizing the date. Might be September here in New York City, but I will end with what happened before COVID and the highlight reel of the events with the smaller robots, and come back play Saturday. If you want to join the robot battle, hop in the chat. We can get you into the Zoom meeting where you can share stuff back and forth with us. I try to make it so that everybody can participate from anywhere with no notice and no skills. So it's set up very easy, and you can check out the reel to see for yourself. Good night.
Has gone wrong. Wally, don't do this. Don't worry, Wally. Your house, don't smoke it. You know what I mean? Like, walk for this side. On your mark, get set, go! Point for this, these guys.
Let's go. Have at it. Oh! Oh, and they're struggling. But they're not giving up. It's still a fight. It's still a fight. It's still a fight. What are they? There he is!
No, yeah. Oh, who got it? Who got it?
That's 2 out of 3.
3, 2, 1.
Go. Go! Have at it. Oh! 2 batteries down. I think that might be a draw.
Yeah, I'm gonna call that one a draw.
That was hysterical.